Okay, now that you understand the unit circle, now that you can produce a unit circle, we can now understand our trigonometric functions by using the unit circle, okay? Now when I say trigonometric function, I say function, really they're the ratios, but we're going to start to understand them as a series of proportions relative to angle measures, and because we'll have two variables, the proportion as a function of the angle measure, we're eventually going to call them trigonometric functions, okay? All right, so here's what we need to understand. I got to take what you already know about sine and cosine and relate it to the unit circle. Then what we're going to do is we're going to cast aside what you have learned so far about sine and cosine, and then we're going to enter a bigger world of sine and cosine. All right, so what you understand so far about sine and cosine is, let's use this one, sure. What you understand so far is that if you have a right triangle with angle, actually let me just draw it on here. There we go, I'll use this as a stencil. So if you have a right triangle, okay, with an angle theta, all right, this is theta, which is, in this case, pi over 3 or 60 degrees, okay? And here's what you learned previously, that the sine of that angle, so we'll say sine of pi over 3, is equal to the proportion of the opposite side. So from here, the opposite to this angle is going to be that side right there, okay? So we have opposite divided by hypotenuse, okay? Now, what we just learned when we did the unit circle is that on the unit circle, the hypotenuse, because the radius of this circle is 1, that makes the hypotenuse equal to 1. And we also learned that the height of this triangle, because the hypotenuse is 1, this short side is 1/2, and that the shorter leg is 1/2, and the longer leg is square root of 3 over 2. Okay? And so now, if we want to identify the sine of this angle right here, if we want to identify the sine of the angle, we would do the opposite side, which is square root of 3 over 2 over 1. Okay? Over 1. Now, anything divided by 1 is equal to itself, and therefore the answer to this is the square root of 3 over 2. So sine equals opposite over hypotenuse is square root of 3 over 2. Okay? Well, that's interesting, isn't it? Because one of the things that we know about this point where the angle measure is pi over 3 is that the coordinates are 1/2 and square root of 3 over 2. So isn't it curious that the sine of the angle happens to also be equal to the y coordinate? Well, it's actually not that curious because look, isn't that the height of the triangle? Isn't that the height of the triangle is the y coordinate? The distance from the x-axis up to the point is also the long leg of the right triangle. And so that is the opposite side from the angle divided by 1. Okay, so it's actually not that curious. And here's basically what I'm trying to say, is that the sine of the angle, the sine of any one of these angles, put here, the sine of whatever angle theta is equal to the y coordinate of the point on the unit circle. And so now we're beginning to understand why it is that we can use the unit circle to understand our trigonometric ratios. Well, it's because these points on the unit circle, the y coordinate is always the sine of the angle. Okay? All right, well now let's talk about the cosine of the angle. Okay, well let's get rid of this. Let's get rid of this. Actually, let's leave this on here, 1/2. Well, now if we want to know the cosine of pi over 3, or theta in this case is pi over 3. Cosine of pi over 3, we know that cosine is equal to the adjacent side divided by the hypotenuse. Well, in this particular case, the adjacent to pi over 3 here, that's this side right here, the one that's touching the angle, right? Or next to the angle, is 1/2, right? So the adjacent side is 1/2 divided by the hypotenuse is 1, and 1/2 divided by 1 is 1/2. Well, isn't it curious that that happens to be the x-coordinate? Well, it's not that curious at all when you consider that we put this triangle in here, and we know that the distance from here to here, okay, which is the adjacent side over the hypotenuse, is also equal to, the x-coordinate. The distance from here to here is the x-coordinate. And so here's what I want to say about that, is that the cosine of theta, whatever angle you're dealing with, is equal to the x-coordinate of the point on the unit circle. Well, it's the point that's created by that angle, the point on the unit circle, okay? Which basically means this, that at every one of these points, okay, so we have here, this is pi over 3, this is pi over 4, and this is pi over 6, right? So this is a 30-degree angle, a 45-degree angle, and a 60-degree angle from here, with the initial side here and the terminal side going to whichever one of those points, okay? That here, the x-coordinate is whatever the cosine of pi over 6 is. And the y-coordinate is whatever sine of pi over 6 is. Cosine, pi over 6 is 30 degrees. Well, cosine of 30 degrees, if you were to get a calculator, we can calculate that. Here we go. Let's make sure that we're in degree mode, right? We're in degree mode. If I just key in cosine of 30 degrees, well, that tells me 0.866, right? Okay, well, what's 0.866? Well, 0.866 is approximately square root of 3 over 2. See, if I go on the calculator here and I go, watch this, I'm going to hit square root of 3, there's square root of 3 divided by 2, right? Square root of 3 divided by 2, and if I hit enter, look at that, 0.866 approximately, okay? So what that means is that cosine of 30 degrees we know to be the square root of 3 over 2. It wouldn't matter which problem you did. If you went to a few lessons ago when we first learned about, or the last lesson, when we first learned about sine and cosine, if you took a triangle and you did the cosine of the 30-degree angle, it wouldn't matter what the lengths were on the right triangle. If you were doing the cosine of the angle and it was a 30-degree angle, it would always come up to the proportion square root of 3 over 2. It would always reduce to the proportion square root of 3 over 2. And then sine is the exact same way. If we hit sine, watch this, sine of 30 degrees, see that right there? We hit enter, probably says 0.5, right? Yep, sure enough, 0.5. That's because the sine of pi over 6 is 1/2, which we already know from doing the unit circle. So the coordinates of pi over 6 are going to be cosine of pi over 6, sine of pi over 6. The coordinates of this point at pi over 4 are going to be cosine of pi over 4, comma, sine of pi over 4. And the coordinates at pi over 3 are going to be cosine of pi over 3, comma, sine of pi over 3, okay? And, whoops, let's close off the parenthesis there, close off the coordinate, okay? And this is consistent all the way around the entire circle. Now, there's a reason that that now becomes a little confusing, and I'll explain that in just a minute. Okay, so now, what we're now going to do can be a little confusing. And so here's the problem. Pi over 6, 30 degrees, pi over 4, 45 degrees, and pi over 3, 60 degrees, we can actually draw triangles that have those angle measures, okay? But down here at radian 0, we can't draw a triangle that has a measure, an angle measure of 0. It wouldn't actually be a triangle. It would just be a straight line. Similarly, up here at pi over 2, or 90 degrees, we can draw a triangle that has an angle of 90 degrees, but it can't be the other angle. In every one of these cases, 30 degrees, 45 degrees, and 60 degrees, it's the second or third angle of the right triangle. But we can't draw a right triangle where the other angle, one of the other angles is 90 degrees. That would not be a triangle. You can't have two 90-degree angles in a triangle because that the two angles, you'd add 90 plus 90 would be 180. There wouldn't be anything for the third angle to have any degrees. Therefore, you cannot have a right triangle that has a 90-degree angle and another 90-degree angle. Now, you can create a right triangle that has a 90 and a 30 and then a 60, a 90 and a 45 and then another 45, or a 90 and a 60 and the other one's 30. But you can't make a right triangle that has a 90 and then a 0. It's not possible. Similarly, 2 pi over 3 over here, okay? Now that is a 120-degree angle, okay? You cannot make a right triangle that has a 90-degree angle and then a 120-degree angle. That's not possible, okay? This line right here has to connect to over here somehow, okay? Therefore, the two other angles of a right triangle have to be acute. They have to be acute. Therefore, theta physically must always be greater than 0 and must always be less than pi over 2, or it has to be greater than 0 degrees and less than 90 degrees. Has to be. So now where we're going is this. With all of these other points, we're going into a theoretical realm, theoretical triangles, or theoretical angles in a right triangle. Okay, so, which is why now what we're going to do is we're going to abandon our concept of the proportions of opposite over adjacent, and opposite over hypotenuse, and adjacent over hypotenuse, and we're now going to simply use the unit circle to understand our proportions. Okay, and so here's what's going to happen. We know that the coordinates of this point up here are 0, 1, right? And we know that the x-coordinate is cosine and that the y-coordinate is sine. So even though in a physical triangle, it is not possible to do sine of pi over 2 or 90 degrees. We can't do, let's do it in degrees, just in case you feel better with degrees right now. We just can't do sine of 90 degrees because sine of 90 degrees is, neither one of the two acute angles can be a 90-degree angle. So there can't be an opposite side because we don't have a triangle. But if we use the unit circle, we can now answer the question, what is sine of 90 degrees? Because we know that sine is always the y-coordinate, and we know that that point has a y-coordinate, and the y-coordinate is 1. So now, where the triangle, the right triangle, fails to give us an answer to sine of 90 degrees, the unit circle succeeds, because we have equated sine to the y-coordinate, and the unit circle has a y-coordinate at the 90-degree angle point. And that y-coordinate is 1. And therefore, sine of 90 degrees is equal to 1. We can also say that sine of pi over 2 is equal to 1. Not because we can do the opposite over hypotenuse proportion, but because we can take the coordinate value off of the unit circle. And this is where the unit circle becomes very valuable. Now that we have a value for sine, all we would now need is a value for cosine. And once we have values for cosine, we can then answer questions about tangent, cotangent, cosecant, and secant. Okay? All right, so if sine of pi over 2 is 1, then what would cosine of pi over 2b? Well, remember, cosine is the x-coordinate. So go to pi over 2 on the unit circle and identify the x-coordinate, which is 0. Therefore, cosine of pi over 2 is 0. Okay? We can now do the exact same thing for all of the points along the unit circle. We can take any one of these radian angle measures and we can identify the sine and the cosine of each of these angle measures because each one of them has an x-coordinate and a y-coordinate. Okay? So let's go ahead and fill in our unit circle here. 3 pi over 2. What do we got here? 5 pi over 3, 7 pi over 4, 11 pi over 6, and then 2 pi. Okay? And now, let's go ahead and fill in all of our coordinates. This would be a really good time for you to pause the video and just produce a unit circle. All right, so square root of 3 over 2 and 1/2, square root of 2 over 2 and square root of 2 over 2, 1/2 and square root of 3 over 2. Over here we'll have negative 1/2 and square root of 3 over 2. Here we'll have negative square root of 2 over 2 and square root of 2 over 2. Over here we will have negative square root of 3 over 2 and 1/2. Here we'll have negative 1 and 0. Don't forget the end. Oh, this one. We got to start here. What about sine of 0? What would sine of 0 be? Well, the coordinate here is 1, 0. The y-coordinate is 0. Therefore, sine of 0 is equal to 0. What's cosine of 0? Well, cosine is the x-coordinate. The x-coordinate is 1, so cosine of 0 is 1. Isn't it interesting that up here at pi over 2, it was 1 and 0, and now down here it's 0 and 1. I find that interesting. Okay. All right. So down here, they're all going to be negative, negative. So this one's going to be negative square root of 3 over 2 and negative 1/2. Here we'll have negative square root of 2 over 2 and negative square root of 2 over 2. This one would be negative 1/2 and negative square root of 3 over 2. Down here we're going to have 0 and negative 1. Over here, positive, then negative. So this one is going to be positive 1/2 and negative square root of 3 over 2. This one's going to be positive square root of 2 over 2 and negative square root of 2 over 2. And this one is going to be square root of 3 over 2 and negative 1/2. There we go. And so now we can answer a bunch of different questions. We can say, basically, that for every single angle measure here, which is 17, starting at 0 and ending at 2 pi. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. This one's counted twice because it's the beginning and the end, and they're coterminal angles. So now what we can do is we can basically answer, well, what is cosine of any one of these? So let's say, what is cosine of 5 pi over 4? 5 pi over 4. And all we'd have to do now is go to the 5 pi over 4 angle right there and look at the x-coordinate, which is negative square root of 2 over 2. So the answer is negative square root of 2 over 2. That is the answer. Now we are done. We can move on to the next question. Okay, let's say that the next question is, well, what is cosine of 11 pi over 6? Okay, so we're going to go to 11 pi over 6 right here, and we're going to identify the x-coordinate, the cosine, right? So that's square root of 3 over 2. So the answer is square root of 3 over 2, and we're done. We're now going to move on to the next question. Let's say the next question is, what is sine of pi? Okay, well, let's go to the angle pi. That's right here. Sine is the y-coordinate. That's right here. That's 0. The answer is 0. It is literally that simple. If you make it more than what I just made it out to be, then you are overcomplicating it. It's very simple. This is cosine of pi over 6, sine of pi over 6, cosine of pi over 4, sine of pi over 4. Over here, this is cosine of 5 pi over 6, and this is sine of 2 pi over 3. It is literally just the x-coordinate and the y-coordinate. If you have a unit circle sitting in front of you, you automatically have all the answers to all of the questions of sine or cosine, as long as you're given one of these angles that are already on the unit circle. Now in another video, in one of these next videos, we're actually going to extend that. We're going to go to coterminal angles. We're going to go to, 13 pi over 3, and you're going to have to try and figure out what sine of 13 pi over 3 is. Well, because you know that 13 pi over 3 is coterminal to pi over 3, then you know that sine of 13 pi over 3 is square root of 3 over 2. It'll be the exact same sine and cosine because it is the same coordinates, because you're going around and around and around one more time on the unit circle, okay? All right, what we're going to do now that you understand how to do that, is we're going to now figure out how to identify tangent, cotangent, secant, and cosecant on these angles where we don't have a triangle available.